All right, thank you so much for joining us today. And in this video, we have this review question that we want to go through together. So stay here with me. We have like 6 questions that we want to go through to deep your own understanding and prepare you for your exams. All right, so let's start with question one. So we have a garden that we have planted watermelon in a row form, right? So we have the mostly when I'm doing this, I do either current or initial. So let's say the initials that we did. So this is like question one, initials, right? So initials we have like 20, right? So let me say the initial is 20 for plants. So let me say plant is equal to 20, right? And it's going with, we are going to produce like average. So let's say that one is the quantity, which is going to be 30, right? Now we are saying that for any additional plants planted, so what we are going to do is we want to plant additional one. So let's say let x be the number of watermelon planted beyond, or the additional watermelon planted. So let me do just beyond the initial 20, right? So if we do that, then it means that we are going to have, like new, so like new ones, like, so we are going to have p to be equal to 20 plus x, like the new one that we're having. Now we want to increase this by just one if we want to do any additional one, and then it means that the quantity, what will be the quantity anytime that we add one plant, we go down by one. So it means that the quantity 2 is going to be 20 minus x. So what will be our function? Our function will be equal to, so this one is like, if we are talking about revenue, then this like price per watermelons times the quantity. So this is going to be 20 plus x times 30 minus x. Nice. So this is what we just need to form. And then the question is, how many extra watermelon planted should you plan to maximize the yield? So the same procedures that we learn, for us to look at the maximization, then we need to differentiate the function and look for the critical values, right? So what is f prime? First, let's even simplify the function before we talk about f prime. So this is the same as 600 minus 20x plus 30x minus x squared. So this is going to give us 600 10x minus x squared. So that's f prime of x is going to give us 10 minus 2x. So let's look for the x. So the x value here is going to be, the x value here is going to be 10 minus 2x is equal to 0. 10 is equal to 2x. Divide through by 2 and our x should be 5. So our x is the value that is going to maximize the function, and we can check that by using the sign chart. So if I put 5 here, remember we are using the f prime, right? So f prime of x is equal to 10 minus 2x. Now pick any value here. We can pick like something like 1. We can pick something like 4, or let me say 6 rather, or let's say here 2 is 4. So plug in 4 here, you see that 10 minus 8 is like positive. So this is like positive. So this is like plus, and this is moving up. Plug in 6 and you get 10 minus 12, and this is going to be less than 0, negative, and this one will be decreasing. So we can see that the function is like concave down, which is going to give us like kind of a maximum something. So it means that at x is equal to 5, actually it's going to maximize the function. But here we want to know, so we need to do an extra of 5. So when x is 5, we are going to get an extra. So how many extra watermelon plants should be planned to maximize yield. So we need to plant like 5 so that we can maximize that. Right. This one did not ask us for the dimension. If it was the dimension, then we need to go and plug it also in. So 5, we're going to maximize the rest of the things that we want to do. Cool. All right, let's look at question 2. Let's look at question 2. But before I start question 2, I need some space. So what I'm going to do is very simple. Let me just clean the solution, and then let's start with question 2. Okay, good. So with question 2, we have our function y is equal to root of x, and we have y is equal to 9. So basically, if y is equal to 9, then the question is what is x? So what we can do is we can just put 9 here. So we are going to have 9 is equal to root of x, and you will see that we can square both sides. So I square 9 and then I square root of x, and then this will be 81 is equal to x. So basically our x is going to be what? 81. So let's try and then do the sketch for this. So when we want to sketch the graph, we are going to have something like this, something like this. Now remember, when you are dealing with root of x, root of x is going with, like, we are talking about above. So this is like root of x. So root of x goes like this and comes like this. But we want the one above the x-axis, so the down will just flip out. So we are going to have 0, and we have, when x is 81, we have 9 for the y. So let's assume that we have 81 here. Then they are going to have a point somewhere here which will correspond to the y-axis, and it's going to give us 9. Right. So we are going to have something like this, and then the area that we are going to think about is this one here. Right. So this is what we are going to talk about. So the first question was like we should sketch between the areas. So this is what we need to do. The last one is for us to do the integration. So for us to do the integration, remember, always it is the above divided by the minus the below. But below here is like on the x-axis, and on the x-axis is when y is equal to 0. And then this graph is when y is equal to root of x. So basically, when we are doing the integration and we want to do it, b is going to give us integration from 0 to 81 root of x minus 0. So minus 0 dx. So this is going to give us 081 root of x dx. So let's go through the process. So this is the same as 0 to 81 x to the power half dx. This is x to the power 3 on 2 divided by 3 on 2 from 0 to 81. This is the same as 2 on 3, x is the same as 3 on 2 from 0 to 81. Plug in 81, so 2 divided by 3, x to the power 3 on 2 minus, when I plug in 0, I'll just get 0. So this is the same as 2 on 3, right? Now what is 81? 81 is the same as 9 squared minus 0. So this one will go to 0, and this will cancel that. So we are going to have 2 on 3 times 9 to the power 3. So this one, since we are not using calculator, I think we can just leave it in this form, and then we are okay to go, right? Because this, okay, we can say that this is the same as 3. This is the same as 9 times 9 times 9. And one of the 3 will cancel here, 3. So we are going to have 3 times 2 is going to give us 6. 8 times 8 is 81. So let's do 81 times 6, 6 here. And then this is, I think, 32, right? Yeah. 8 times 6 is 32. This line, no, it should be more than that. So 8 times 2 is 16, 16, 16. So this one should be 48. Yes. So this is going to give us 486. Yeah. So basically that's what you are going to get for the first and then the second question. Right. Now let's look at question 2. Question 3. Question 3, we want to look at the relevant critical values. When you say relevant critical values, because of the domain, that's the reason why we are naming it relevant. Right. So let's go through that with question 3. So question 3, we have f of x, which is equal to x cubed minus 3x squared plus 1. So when we are saying that relevant, as I said, we need to look for the critical values inside the domain. So for us to find the critical values, we need to differentiate the function. So what is f prime? F prime of x is equal to 3x squared minus 6x, right? Good. So what can we see here? We can see that we can factor 3x out. When I do that, what am I going to get? When I factor it out, I'll have x minus 2. So when I multiply this by this, I have this by this, I have that. So this is not difficult for us to see that when x is equal to 0, this one will be 0. And when x is equal to 2, this is going to be 0. So x is equal to 0 and x is equal to 2 is the critical value. But let's pick the relevant one. Which one is in between -1 and 1? Of course, 0, right? So here we are going to say that A, the relevant critical value, the what? Okay, the relevant critical value is 0 because it's in the domain. So 0 is in the domain, -1, 1. So become relevant. So now our critical value, which is 0, will help us to solve the B, because now we want to look at the absolute maximum and absolute minimum. So let's look at B. So B here is like, let's have a table and let's put our domain, right? So domain is -1 and 1, and we're able to see that one of the critical value is inside the domain, which is 0. So I plug in 0 here. So this is S, this is f of x. Let's look for f of -1, f of 1, and f of 0. I love f of 0 whenever we are dealing with polynomials, because I plug in 0, everything goes 0, and I left with the constant. So this is going to be 1. Let's plug in 1 and -1. When I plug in 1 here, I'll get 1. Minus, when I plug in 1 here, I'll get 3 plus 1. So this is also going to give us -1, which is also very cool. Let's plug in -1. When I plug in -1 here, I'll have -1 minus 3 plus 1. So this is going to give us -3. So what is the minimum? So this is the minimum and this is the max. So we can conclude that absolute max is 1 and absolute minimum is -3. Good. So with absolute maximum and minimum, anytime you are taking the exam or a quiz, you should be able to score everything. If a question is being given there, you should be able to score everything from there. Right. So that is basically what we just need. Let's look at question 4. Then we look at the last 2 questions. Then we are done with this video. Right. So question 4, we are just doing the normal integration that we are doing. Right. So let's just go through that. So this is going to give us x to the power 4 divided by 4 minus x to the power 2 divided by 2 minus 3x from 0 to 1. So if I want to simplify, this is x to the power 4 divided by 4 minus 5x squared minus 3x from 0 to 1. So I plug in 1 and I'm going to have 1 over 4, right? So I plug in 1 here. 1 to the power 4 is 1, so 1 over 4 minus. When I plug in 1 here, 1 squared is 1. 1 times 5 is also 5 minus. Basically, this one is going to give us 3 minus. When I plug in 0, everything will go to 0. So I'm going to have 1 over 4 minus 8. And this is going to give us 4 times 8. What is 4 times 8? 4 times 8 should be 32, I think. Yeah, 32. So this is going to be giving us minus 31 divided by 4 as our final results. You can use calculator to do that. So it's kind of definite integrals is now also becoming so easy for us because we've been doing it time to time, right? So this is going to give us minus 31 divided by 4. Okay, let's look at B. Let's look at B. So with B, what we can do is we know that A plus B divided by C is the same as A over C plus B over C. Is that right? So we can just write this one as integration x to the power 3 divided by x to the power 4 plus 2x divided by x to the power 4 minus 3x to the power 4 or the x. Do you agree? Yes. If we agree, then we can also write this one as 1 over x, right? Because x cubed divided by x to the power 4 plus 2 divided by x to the power 3 minus 3 divided by x to the power 4. Then we can write this one as integration 1 over x plus 2x to the power negative 3 minus 3x to the power minus 4 or the x. So you see that anytime I'm doing integration and the integration is not in the polynomial function form like this, I don't start just doing the integration. I need to be doing simplifications before I start. So now it's good for us to now start doing the integration. We know that when we integrate 1 over x, we need to get the natural log of x. So this one is indefinite, so I need to put the absolute there. Plus 2x minus 3 plus 1 divided by minus 3 plus 1, then minus 3x minus 4 plus 1 divided by minus 4 plus 1. Then I add my plus constant. Let's just do some small simplification and then we are done. So ln of x, then plus, or this one, okay, plus 2x to the power minus 2 divided by minus 2 plus, minus 3 x to the power minus 3 divided by minus 3 plus c. And our final simplification will be ln of x minus x to the power minus 2 plus x to the power minus 3 plus c. Good. So that's what you are going to get for the B, right? That's what you are going to get for the B as well. So now let's see, let me clean the board and then let's look at C. So this is going to give us natural log of x minus 2 plus x to the power minus 3 plus c. Good. So let me clean the board and let's do the last one. We have like 2 questions more after this one, then we go. Now this one, I can write this one as integration from 1 to 4 to x to the power 1 over 2, then plus 3 divided by x to the power 1 over 2 dx, right? Still, I'm not done with the simplification. So 1 to the power 4, 1 to 4, sorry, x 1 over 2 plus, I can write this one as 3x to the power minus 1 over 2 or dx. Now that I'm done with the simplification, I can now start with the integration. So 2x to the power 1 over 2 plus 1 divided by 1 plus half, then plus 3x to the power minus 1 over 2 plus 1 then divided by minus 1 over 2 plus 1. This is from 1 to 4. So what do we get? 2x to the power 3 on 2 divided by 3 on 2 plus 3 times, or 3x 1 over 2 divided by 1 over 2. So 2 divided by 3 on 2 is the same as 2 times 2 over 3. So this is going to give us 4 over 3 x to the power 3 on 2. Then 3 divided by 1 over 2 is the same as 3 times 2 over 1, which is going to give us plus 6 half. Then we are moved from 1 to 4. This is from 1 to 4. We are done with the simplification. Let's plug them in. So 4 divided by 3, plug in 4, 3 on 2 plus 6, 4, 1 over 2 minus, I open my parentheses, 3 over 4, I plug in 1, 3 on 2 plus 6, 1 over 2. Right. So we have been doing this and then we are getting good with it, right? So this is going to give us 4 over 3. So this is, if I'm not using calculator, I can write 4 as 2 squared, 3 on 2, right? Then this is like 4 to the power half, like that's the square root of 4. So this is basically 2 minus 3 over 4 times 1 plus 6 times 1. So this 2 here will cancel this 2 here, and we are going to have 2 to the power 3, which is 8. So 4 times this times 8 plus 12 minus 3 over 4 plus 6. So what is 8 times 4? That is 32. So 32 divided by 4 plus 12 minus, what is 6 times 4? That is 24. So you're going to have 27 divided by 4. Good. So let's basically add this and this first. So since the base are the same, when you do the subtraction, we are going to have 5 divided by 4. I think so. Yeah. Plus 12. Then now we can add. So 12 times 4, 8, 48. Good. So we are going to have 48 here. So this is going to give us 53 divided by 4. That's what we are going to get at the end of the day for the 4. Let's do the last one and then we are done. Right. Okay, so you are looking to fence your backyard, but only need to fence in the 3 side. Okay, so okay, kind of we've done this question a lot. So this kind of we are leaving just one side and then we need to fence the other 3 sides. Good. So let's assume here is X, here is Y. Right. So what happens? West side is already fenced. So let's assume that this is the west side. West. Good. Yeah, what happened? 500 fencing up. So we have 500 fencing up. So this is going to be 500 is equal to x plus y, and 500 is going to give us, we are going to have 500 is equal to 2x plus y, making the y the subject will be 500 minus 2x. Then what are we even looking for? We want to look at the largest size. Okay, so let's find the area associated to this. Okay, so let's assume that the area for this one is xy, right? Then we know y to be equal to this, so let's plug in y here. So this will be a is equal to x times 500 minus 2x. Good. So let's multiply through and we have 500x minus 2x squared. Hmm. Now, since we want to look at the largest size, then we need to differentiate the area. So a prime will be equal to 500 minus 4x. Let's find for x by equating it to 0. So 500 minus 4x is equal to 0. 500 is equal to 4x. Then what will be x? So we are dividing 500 by 4, and basically what are we going to get? So 2 goes to 500 by 250, and we want to divide 250 into 2. So what are we going to get? 125. Is that right? Yes, of course. This is supposed to be right. Yes. So our x is going to be 125, because when I multiply this one by 4, I'm going to get 500. So that is x. So since we are looking at the size, then we need to look for y, because the sizes are x and y. So y is equal to what is here, right? So we are going to have this to be equal to 500 minus 2 times x. What is x? 125. 125. So do the multiplication and let's see. 500 minus 125. 2 times 125 is, I think, 250. Yes. And when I do the subtraction, I'm going to have y to be 250. Good. So the x values and the y values, x should be 125 and y should be 250, so that we can fence the wall. Let's do the last one, and then I think we are done with this video, and then you are done. When you are done watching all this video, I think you will be prepared, fully prepared to write your exam. So basically, since this is x to the power 3 and this is 2, we can do U substitution, right? So we learned how to do U substitution. So what I'm going to do is, for a, I'll let u to be equal to 4 minus s cubed. So I'm picking everything on the top. So what happens to my function? Now the integration will be like x squared e to the power u dx, because everything on the top is equal to u now. Now, when you are done with that, group like terms. Group all x one side and u one side. So u here, and then I combine the one with the x. So now what I need to look for is, I need to look for x squared dx from here. So let's go through it and see. So this is going to be du over dx to be equal to minus 3x squared. Multiply both sides, cross this, cross that. We are going to have du to be equal to minus 3x squared dx. We have x squared dx, x squared dx. The only problem here is minus 3. So we can divide 2 by minus 3. So we are going to have du over minus 3, which is equal to x squared dx. So this is the same as this, and we need to replace by that. So we are going to have u x times du over minus 3. Good. So this can be written as 1 over minus 3 out u du. Now we said how to differentiate an exponential function is maintain the function divided by the derivative of the top. So when I differentiate u with respect to u, I'll get 1. So plus c, don't forget. This is minus 1 over 3 e u plus c. Now, since our function is in terms of x, our final results too should be in terms of x, not in terms of u. So it means that we need to go and look for u. U is the same as 4 minus x cubed. So finally, we are going to have 4 minus x cubed plus c. So this will be the final results for the A. Let's look at B. Now, what can we do for B? Now, the question is, can we also do substitution by integration by substitution using b. Yes, yeah, we can do that. Why? Because when you look at the function, you can see that if I'm putting some x on the top, like here, I'll put x and put 0. X to the power 0 is 1. So you can see that the degree here is 1, degree here is 0. So still integration by substitution will work from there. So here I'll pick u to be equal to 2x minus 1. Right? But if this one, for me, like if this one I'm doing it, I can just see that this is going to give us 4 ln of 2x minus 1 divided by 2 plus c. Right? But let's go by u substitution. You have a lot of them. So let's go. Since u is equal to 2x, this is going to be 4 divided by u dx. So we just need to look for, the x. So let's do that. Du over dx is equal to 2. So du is equal to 2 dx. So we need to look for this. So we need to divide 2 by 2. So u divided by 2 is equal to that. So let's replace the x by that. So this will be 4 over u du over 2. This is nice. 2 cancel itself, 1 cancel here, 2. So our integration now becomes 2 out, 1 divided by u du. So what do you need to think about here? This is 1, so we need to think about the natural log, which is ln of u, plus c. Now we don't know u, so we need to go and plug in u. So what are we going to get? We are going to get 2 ln of 2x minus 1 plus c. So you see that this one was the same as the results that I wrote, first one. So I said this is the same as 4 natural log of 2x minus 1 divided by 2, right? Let's see. So if 2 cancel itself, 1 cancel here, 2. This is the same as what is here. So we have shortcut to go through. So this is what you're going to get. Let's do the last one. The last one is fun. Let's have fun with it, and then we just go. Now the last one, the question is, can we use integration by substitution? Let's check. The degree here is 1, the degree here 2 is 1. No. So it means that we cannot use integration by part. Here we did integration by substitution because the degree here is more than this by 1, right? So you can use integration by substitution when the degree is less than by 1, just 1. Even if it is 2, you cannot use integration by substitution, because when you do that, some of your function will be in terms of x. So here we are going to use another one, which we call it integration by part. So this is how it is. So u divin is equal to u vin minus vin du. So we are going to compare the integration. So the question that we are doing here is 4x e to the power 3x dx. So it means that everything will be equal to this. So now let's share. Let's choose our integration. So let me choose this integration with this integration, right? So let me choose my u. I'm choosing u to be equal to 4x because it's very simple for me to differentiate 4x and get it to constant term or 0 than when you pick u to the power x. When I pick e to the power x, there's no way I'm going to differentiate it to get to constant. So I pick that. So if this is the same as this and I'm picking u to be equal to 4x, then everything left is for what? Divin. So divin here will be equal to everything here. So divin will be equal to 3 dx. This is what I'm going to get, which is so nice. So what am I going to do here? From the formula, we need u. Yes, we have u. We need vin. We don't have vin, but we can get vin here. Now vin is differentiated, so we need to integrate both sides. So I'll integrate this, I'll integrate that. It is nice to see that d will cancel this and then have vin to be equal to. Now when you integrate e to the power 3 exponential function. It said maintain the function and divide it by the derivative of the top. So what do you get when you differentiate the top? 3. Here we are not adding constant because we are not done with the integration. So now we have u, we have ven, but we need du. So where can you get du? We can get du here. So du over dx is equal to 4, and du will be equal to 4dx. So everything is here. We have u, we have ven, we have du. So we can just go through the process. So our integration for x e to the power 3x dx is equal to, remember we said this is the same as this. That's what we were able to use to find our u, ven, and du. So we are going to use here. So this is equal to u is 4x, u is here, which is 4x, times ven is this. So we are going to multiply this one by e to the power 3x divided by 3 minus integral of, so minus this, but we have ven again, so ven is e to the power 3x divided by 3 times du, but du is 4dx, 4dx. Very nice. So now that we're able to use integration by substitution, the rest is just simplification. So this is 4 over 3x e to the power this minus, I can factor these guys out and have 4 over 3 e to the power 3x dx. So finally, we are having this x e to the power this, and we are going to write our final answer very big because we are so tired, and we've gone through this long journey, plus c. So now we are done with the integration, so we can add plus c. So our final results, we are going to write very big, then we'll put a box on it. Is going to be, let me use green. Our final result is going to be 4 over 3 x e to the power x minus, then I'll multiply this one by this. I'm going to have 4 divided by 9 e to the power 3x plus c. So this is our big final answer that we are going to get at the end of the video. All right, so this is the end of the video, and I wish you all the best in your exams. See you in class on Tuesday, and I know you are going to do well. Yeah, I wish you all the best, and see you also in the next video.